Hey guys, it's Mr. Haas here, and today I want to talk about some of the forces that are going to be acting on the egg as it falls towards the ground off the top of Rocky River. Because that's the experiment. Your job is to create a container that can safely protect an egg from cracking if it's dropped off the top of the school. And we're actually going to do that experiment with your containers to see who is successful and who can do that. So I'm super excited about this. So to help you out, I want to talk a little bit about the forces that are in play. So you already watched a video last week about gravity. So gravity, we know, pulls objects towards the center of the Earth. And in this case, since we're on the surface of the Earth, it's always pulling us down. So when we take an egg and we drop it, gravity pulls it down. So gravity is our enemy. So here's something I want to talk to you about gravity first. So here's my egg, a little bit bigger than yours. This is an emu egg. So same shape though. It's just easier to see here. So when we take an object and we drop it, all right, gravity actually accelerates or speeds up that object towards the Earth. And what that means is the higher up you go and the longer an object falls, the more it speeds up. It's like if your parents were driving you and they press the gas pedal and you kind of get pushed back into your seat a little bit, you're speeding up. You're going 5 miles an hour, then 10, then 15 miles an hour, then 20. That's what happens when you let go of something. And it's hard to see because it happens quickly. Um, but when you drop an object, it is actually speeding up. When you let go, it doesn't just start and go the same speed. So that's important to know because the higher up we go, the faster that object is going to hit the ground at. And that's really important. So because we're dropping it off the top of the school, you're not going to get a chance to really test it out. Now, you are going to be able to test in class a little bit. The hard part about that is that you're only going to be able to test from about probably an 8 or 9 foot drop, where we'll be on top of the school, will be much higher than that. So what that means is that your container is going to hit the ground at a faster speed when we actually do the test. So you really got to prepare for that, okay? So what does that mean? Well, think about it. Now let's talk about the forces. Let's think about if you're playing with somebody and they have a ball, right? And they softly throw the ball at you and it hits you and you're like, well, barely felt it. Whereas somebody took a ball and threw it really hard at you or fast at you, when it hits you, it hurts. And the reason for that is because the faster that object is moving when it hits you, the more force it hits you with. And that's important because the higher up that we drop the object, the faster it's going when it hits, which means the more force that is acting on it when it hits the ground. So let's talk about our forces. So I'm going to use a piece of modeling clay here. And the concept I'm about to talk to you about is kind of difficult to understand. But give it a minute and it'll start to make sense. So if we have this piece of clay, we have gravity pulling this. If I were to drop it, gravity is going to pull this piece of clay down, okay? As gravity pulls it, it's speeding up, and then when it hits the ground, something interesting happens. We know that this object applies a force to the table. However, the table applies an equal force back up at the clay. And we know this because when the clay hits, it doesn't go through the table, which means the force of the clay pushing down and the force of the table pushing up must be equal. If they weren't, then the ball would go through the table. So this is why if we were to drop an egg and it hit a hard surface, it would break because there's actually a force being pushed back. It's the same reason that when a ball hits your hand and it hurts, it's because your hand is applying a force back, the ball is applying a force, and you're feeling that as pain in your body. Okay, so what that means is that the faster it goes, the harder it hits, and the harder the ground is going to push back at it. So when you're building your container, we have to account for that. So I want to show you something interesting here, okay? So I have this piece of clay. I've made it nice and round, okay? Now, if I were to drop this clay on this table, we get this flat spot. That flat spot is because the table pushed back up against the clay and the energy actually was able to flatten it and make this nice little flat spot. So that's what happens when we drop the clay on something hard. Now, if I was to drop, and I'm going to roll it up again, if I was to drop it on something like this pillow here, this clay from the same height, now there is no flat spot. And what that means is that the force must not have been as strong, which is interesting because I dropped it from the same height. So we'll do the same thing here with this piece of styrofoam. Okay, a couple pieces of styrofoam. We drop the clay. Okay, this one gave us it moved here. Let's see if we can get if it gives us one. Okay, this one you can hear it, so you know there's a little more force. So if there was a flat spot, I'm having a hard time seeing it, but we could definitely hear it. But again, because this is nice and soft, it did not leave us a flat spot. Now let's try just a regular piece of cardboard, and we get the same effect as the table. We get this flat spot on the piece of clay. So what does this tell us? Okay, and why does this work? Well, what happens is when the ball is falling, as it falls and gravity pushes it or pulls it down, when it hits here, it actually will push down into the styrofoam, just like it. Maybe I'll show you with the pillow better. It pushes down with the ball, the clay ball pushes into the pillow. Now, what you notice the pillow does is the pillow squishes in. And what this does is instead of stopping the clay immediately in the same spot, it allows the clay ball to begin to slow down, which means less force is being applied to it, which means that it is much safer. So that's very important when you're thinking about designing your egg container. You're definitely going to need the cardboard because that's going to give that nice, that's going to kind of hold everything together for the container. But inside of it, you want to think about what you can use that's going to keep that egg safe and sturdy, but also using this concept of if I have some squishiness, if I have some stuff like that, it's going to absorb some of that energy and protect my clay ball, or in our sense, the egg. So that is really important. So hopefully this makes sense. It's the reason why we have airbags in cars. They offer that slow down as your face is going. Yes, it protects you from hitting things, but they're built in a certain way that it'll slow it down, your head and your body, before it does hit anything. Instead of just doing a real quick bam stop. It's the same reason we have cushions in football helmets. All of these things are because we want whatever we're trying to protect, the egg or our brain, we want it to slow down slightly, not just stop. When it just hits something hard and stops, that's when the damage occurs. So keep that in mind as you are thinking about your designs this week. I cannot wait to see what awesome stuff you guys come up with. Have a great day.